Okay, this is second part uh, of the asynchronous. It's chapter 7-3. So we did this one, and we noticed that from the parents population is normal. The distribution is the sample mean of the distribution, sampling distribution is also normal. So now this is the second activity. And we have to choose skewed, okay, this time. So skewed is this, okay? So now it's skewed information here. And choose size 2 and size 5 and create animator. So this is size 2 here and size 5, okay? And the animation. So, okay, so now you see, so now that's, you know what's going on. The same thing to the previous activities, yeah? So if I do a couple of times, you can see the distributions, yeah, like this. So since this is activities, is if distribution is most likely is skewed, right? So more uh, um, it might affect if I clean up here. So this and choose. I think I will have to choose 10,000. So we have to hit 10 times, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as you see this, now it's 100,000 here and 100,000 here. I think, I'm sorry. Take only 10,000, sorry. So let me clean up again. Okay, so I didn't read it carefully. And then clear 3 and take 10,000 and what you see. So 10,000 is only one hit. So this is it. So if it's 10,000 and sample size 2 and sample size 5, so it's still skewed. And this is also a little bit skewed right, you know, but this is getting closer to normal, yeah? Next activity, change the sample size n equal 10 and n equal 16 and do the step 1. So n equal 5 and n equal 16. Wait, I'm sorry. N equal 10 and n equal 16. So this 10 and 16. Okay, so let me try 10,000. Okay, now what can you see? This is it's getting okay, right? And however, it's a little bit, I could say a little bit skewed right here. Yeah. So so did you confirm that you saw step 2? Well, oh, okay. So what we have to do is one more different pair. So different pair is 20 and 25. That's step 3. And I hit the 10,000. Now, this is quite normal. This is okay too, right? So clear the page and select the custom and distribution endpoint. So one thing I can confirm, and if you can take a look of the distribution here, you can take a standard deviation. If it's skewed right, if you get the sample mean of sample distribution and sampling distribution, you get the it's become closer to normal. And our textbook, if n equal 30, and at this n equal 30, you can consider this as normal, right? And so it's still 25, and this is I can prove this is nearly normal. Okay. Next activity is I have to clear the page and click on the point population graph, insert the bar of the height, or click the point of horizontal axis, drag the define to make distribution that looks like strange you can. So you can do custom here. First, you have to clean, go to custom, and I create that crazy distribution like this. And you don't know what's going on. So it's some of them high, some of them is like this, right? So now with the crazy distribution, okay, do the step 1, 2, 3. So okay, let's do step 1. Step 1 is 2 and 5, right? So it's 2 and 5, and we get the mean, and let's see. So I did 10. So if it's crazy distribution like this, if it's sample size 2, it's still crazy. But if sample size 10, it become closer to normal, but it's still a little bit funky here. But if I choose clear here, same distribution. If I choose this one, 10 and 16, right? And 10,000. Now, you become closer to normal. So one more activity you have to do. Clear here. Sample size 20 and 25. Sample size 30 is okay to consider that as normal distribution, right? So let's see if I plug in 10,000. Okay. So now, mean 16. Mean here is 16, even crazy distribution like this. So mean is always same. Now, standard deviation is 2.16, so it's not so much extreme. This one is really extreme. It's 10.82, right? So it become normal. It become close to normal. Okay, so that's the summarize. Number 5. Let's see number 6. Number 6 is just showing this. So if you can read this, maybe not here. And maybe this is the activity I just did. A, B, C, D, you can take a look and you can read the, what's going on from your note. Okay, this is central limits theorem, right? So the central limits theorem says if the population distribution is normal, then so is the sample distribution of X bar. Okay, this is true no matter what sample size n is. Okay, that steepness, even normal, it's a steepness, it's become little kind of steeper, Now, if if the population distribution is not normal, central limit theorem tells us that the sampling distribution of X bar will be approximately normal if in most cases if n equal or n is at least 30. Okay, we did the distribution of 25, but if this is 30, it's much clearer, so we can treat as normal. I hope you understand. I will create more videos. I'm planning to create more videos for not only asynchronous, but also for the for review, test review. So, but now tonight I just make those 2 videos and you watch, and I would like to hear your feedback. And so this is weekend music for you. And if you're watching this far, this is the composer. His name is Henry Mancini, and called Two for the Road. Have a nice weekend.